Alright, good afternoon and good morning, everybody, wherever you are. Um, my name is Oshim Adoh, and I'm here representing or showing you the behind scenes of what this game is about. Now, this is Godot. Godot is basically a free open source game engine like Unity or Unreal that basically helps us make our games. Now, you're probably wondering, what is all these? What's all this? So I'm going to give you a basic overview of what this environment is like. Now, obviously, this is our main view scene where we can see or manipulate what exactly is going on. Okay, now let me start. Let me stop here. All right. So first, this is this is where we this is the tab where we import our things like scene, project, debug, editor, help. Yeah. Next, we have our scene port, which basically helps us to make our scenes. Scenes are basically what makes a game. So the more this is where we can manipulate it. Next, we have where our import window where we can import all the resources that we need. This is our outputs where we can see like exactly what's going on. It's also used for animation, audio to manipulate all that. This is our main window where we view what's going on in our scenes and how it interacts with our node tree. So we have different ones that you can see here. So then we're starting with our menu scene. This is our menu scene. A menu is basically where we're starting off with. So to start off, we have to start with the menu. With menu, we come to our sprite, which is basically this whole picture here. This is our picture here that we imported as the background for our sprite. Then with Godot, we use nodes that's basically used to build our scene. So to create an actual menu with actual boxes, we created a VBox container, each with 3 buttons: start, option, and quit. Now with that, you can see that we can now make different buttons. We also added audio, but then yeah. As with all of these, it's useless if we can't actually click it. So what we do is that we attach a script, which is basically the code that works with our scene. So if we come to script here, you can see this whole code here that dictates how our menu scene is going to work. So we have extends. We're going to see extend a lot in this because extend basically means that it basically extends to the node that it's being used in. So control is the node of VBox container, or menu. So function basically is the function that we're defining about what we're going to do. That dictates what we're going to do. So function on start press. If we press the start button, we do this is what's going to happen. Now start in itself starts with when we press start, we have to change to our first scene, which is basically here. Then if we press quit, we basically quit the game. So if you go to our first scene, although before we go to our first scene, we want to show you the other scene that we ended up with. Now with this whole scene that's going on here, we had to at least start with our environment. So you can see this is how we can just see. So go to the game that we try to make Eternal is a 2.5D game that has a 2D character within a 3D space. So we do this by defining a world node and then having children under it. So we have our player, we have a camera, we have lights, we have a world environment that dictates how exactly how our world is going to look like. So you can see it's quite dark. So we wanted our light to look really good. So yes, so I'll explain our player node, but I'll use it with this. This is going to be our example. Now, with this node, Kinematic Body basically says is basically a body, an object that we the player can move, but we're not moving this because it doesn't have the script. Well, we'll get to that later. So under the body, under our kinematic body, is useless if it doesn't have a picture added to it. So since it's a 2.5D game, we have to make sure it's a texture that moves in a 3D space. So we have to use using the Sprite 3D node. Sprite 3D node that we manipulated the texture to basically look like this. We also have another one, but that's for the shadow. You probably can't see it if I raise it. No, oops. If I raise, well, never mind. You can see it's on this person here. You can see that he has a shadow. Not that we can't cast actual shadows on him, but because he's a texture, he wouldn't actually cast one. Then we'll get to our scene trigger later. So this is basically what a basic environment in Godot uses. But then the question is, how do we animate this character? So to animate this character, we need to, yes, this is our character. We're going to name him Steve. Well, say hi to Steve, everybody. So with Steve, we have established that he has a texture. Now if you come under here, we can see that we have defined the number of frames that he's going to be in. Manipulating it, you can see that we can come to his original sprite sheets. Yes, this is our sprite sheet for Steve. But we need, well, our sprite sheet is basically going to define the number of actions that he's going to take. So we have different ones of how he's walking. But we want him to be in the default state, so that's 4x4. Looking left. I wanted it to look elsewhere, but we're going to use it for now. Use this for now. You can also do one. Oh wait, no. You can see that didn't actually work. So we're going to use 4. I can just type 4x4. Yeah. So with this, we need to, how are we going to animate it? We use this using the animation player node. And okay, go back. Animation player, you can see now that we have our animation player here, down here. Now we have a timeline. We can normally see this in Godot and things like Blender on our timeline or how to animate. So we can see that I've already built his frames by frame to show him how he moves. Now, if I play this you can see that he's moving down. Now, this is basically how we're going to do this. We're going to establish that we have different states for him to go. We have idle down, we have left, we have right, we have up, and we have down. So, yes. This is our character and his moves, but then this isn't enough for us to actually move, because we'll see later why this isn't a problem. Why this is a problem. So we move to our animation tree node. Animation tree basically feeds off our animation player node that gives us the information to work with. So we need to work between and the player moving from his start idle to the walk. So this is a graph that represents our player. Our player represents the middle here. If he moves, you can see that he's moving along. But you're wondering, why is this looking left and he's looking right here? That's because in coding in games, everything is upside down. So if he wants to move down, he looks up and all that. But you could possibly manipulate it. You could be cheeky and try to manipulate it to try to work for you. I kind of did this, and we'll see how I did this later on. So yes, he moves between. We have to instantiate to tell Godot which animation player we want to use. So up is our idle up, idle down, idle left, idle right. But idle right here, idle left here. So yeah, it works as a cycle. When this one ends, this one continues. When this one ends, this one continues. So then how is this all represented? So we need to go to our player scripts. So yes, like I said, extends to our kinematic body. That is what's don't worry about, these are all failed attempts by me to try and change scenes, so don't worry about that. Our max speed is how basically a variable that we're going to use to determine how fast our body is going to move. Now, this is a very important statement. Vector 3 in itself, we're not supposed to use vector 3 because we're actually supposed to use vector 3, but most people will say use vector 2. But the reason why I'm saying use vector 3, as it states, using 3 vectors, x, y, and z, we're not necessarily using our z-axis, but we are. Now the thing is that with vector 2, we can only move on the x and y axis. But if we represent that in our 3D game, we're only going to moving up and left and right. We will move up and down like we had in the first time. So with this, I'm show you how cheeky we got, but I'll explain that. So yes, this basically calls on our animation player, animation tree, to basically say we're calling on these as a reference. So yes, so this is our physics state function that basically states how our object is going to move. So our inputs on the x-axis, UI right, UI left. This is our keys, the left key, the right, and this is actually our left key, and this is actually our right key. Oh, I could change this, but never mind. Our input on the y-axis. This is a very important step. We could change this to z, but then that will be a really big problem with our animation player and animation tree, because they do not work on the x and y on the z axis. They only work on the y and x and y axis. So to counteract this problem on how we're going to move our player, what I did is to have our player, is to have our world, and basically rotate it. Yes, to rotate it such that our x-axis is here and our y-axis is now up and down. So if I were to show you how it would work, you will see that it will move up this way instead of moving up and down if we had our z-axis. So coming back to our script, this we're using print to show if we're moving. We'll run the game again, and I'll show you again. So this is a statement, an if statement, that basically says if our input vector on our vector 3 plane, if he moves, he moves from an idle, it calls on idle, then moves to walk. So if we're not moving, we're going to be in the last idle position that we were walking in, so that he doesn't actually return to another state. We're moving from this state to this state. So then our velocity, and this statement of velocity basically says our input vector times our max speed, which was 12. We can reduce it to show to be slower or fast, or however we want it to be. So if we're pressing a button, we are walking. Else we're in idle, and we're going to be in the last idle or our graph of how we were. So yes, this is our player script. Now I want to show you our real outside scene. Give me a moment. It's lagging. So yes, you can see that I've already rotated this whole scene that we have so that our player can move. We could probably fix this, but I'm not nearly as experienced too. So let's set this back to 0 for example. Whoops. So yes, our player. There was something else I didn't explain in the first one. We have collision bodies. You see all these boxes around our scenes. These are basically objects that tell our kinematic body whoops, yes, that tell our kinematic body um what he can and what he can't bump into. So if we're playing the game, he can't bump into this wall, he can't bump into this house, nor can he walk into the lamppost. He can simply walk on where he is. It's a tedious thing to do, but then it's how games are run. So if I was to explain how we basically lit up the scene, um, Godot doesn't accept lights from other sources, so we couldn't import lights from Blender. So what we did was that we created textures. We created our own light source in Godot using the world environment node. The world environment node basically gives us a background with HDRI that basically states how we want our scene to look like. We also use directional light. We also had a directional light for extra to make it look better. Actually, this doesn't look half bad, but I put this off because I didn't want to deal with it. I think this is actually a bit better. So we can leave that on. Now, because our lights weren't imported, we had to create our lights. So we have spotlights that radiates lights at each of these places. So yes, we also had to texture windows to show that okay, it's nighttime. So we created an object that basically is glowing. Now we have to set this within our world environment node, which was a world environment node around, yes, here. We had to set glow on, auto exposure on, and SSS reflection, because that actually shows that okay, our lights are reflecting, bouncing, and working around our game. Now this is basically how you set up the game. But then you're asking, how do we move from one scene to another? Now we do this through, if we go back to our first scene, which was actually the first scene we were supposed to make, if we come back here, you can see that we have a scene trigger node. Our scene trigger node is basically a node that states that that is basically a collision that's basically a collision shape that shows that we can't interact with this, but this is an exception in the sense that it's the only one that was scripted. So if this is in contact with the player, we can now call on the function that we made in our first menu, get tree.change scene. So basically we change scene from one scene to another. That's basically how I figured out how to, but there's a lot of problems with trying to detect bodies, as it's not quite explicit in Godot. So yes, this is our game and how tedious it was to create that simple scene, but with so much things going into it. Thank you very much.